So now we'll be covering the third disaccharide that we have, and this is lactose. So lactose is a disaccharide, so it has two monomeric units or gives two monosaccharides on hydrolysis. And what are these two monomeric units? So first we have beta D glucose. Now what is beta D glucose? We are very well aware of this. So if we start from this, the first, second, the third, the fourth, and the fifth carbon, and we proceed in this manner. So we have got OH being trans to each other on the first and the second carbon, and the rest of the structure looks same as the alpha D glucose. So OH, H, then we have H, OH, and then we have CH2OH and H. Now, so this is the beta D glucose. Now, the second monomeric unit which we are going to take is known as beta D galactose. So, this is called beta D galactose. Now, how to draw this? If you see carefully, what we're going to do is that we will draw the OH and the H at similar position to beta D glucose, but it differs only at one carbon position, that is at C4. So at this particular, so numbering from 1, 2, 3, 4, and 5, the fourth carbon over here, the placement of OH and H are different than beta D glucose, and the rest of the structure looks exactly the same. So we have CH2OH over here, H over here, OH over here, H, H, OH, and since it is beta, so first and the second OH will be trans to each other. Now, if you see this clearly, so what we just saw that in beta D glucose, OH was here and the H is at this position. But in beta D galactose, the only difference is that the OH and the H position is switched from the beta D glucose. Now, what that infers, that what is this part telling us about both of them, that both of them are epimers or rather anomers because they are cyclic. So both of them will be anomers of each other, differing only at one configuration at only one carbon, that is the C4 carbon. So both of them are actually anom. Now moving on to the next part about how we are going to be forming the lactose when we combine both of them. So we'll be taking the C1 and the C4 carbon of both of them, and now which atoms will be lost? The OH from C1 of beta D galactose and the H from beta D glucose. So when we lose this, both of them, we'll get an ether bond being formed over here, and the H and the H remains over here. So we have got this new structure. The rest of the atoms remain at their places where they were originally. So now we have got ourselves the glycosidic linkage also, and we saw that the glycosidic linkage is between the C1 of beta D galactose and the C4 of beta D glucose, which are anomers of each other. Now, let us just complete the valencies. Also, let us now come to the anomeric carbon for seeing that whether lactose is a reducing or a non-reducing sugar. So, if we see the anomeric carbon is actually the first one on both of them. So, when we come here, when we come to lactose, when we join these two monomeric unit, we notice that the C1 of beta D galactose is destroyed in the process of forming ether linkage, but the C1 of beta D glucose, that is this particular carbon, remains intact. So this beta D galactose unit will act as a non-reducing sugar, as a non-reducing unit, and but the beta D glucose unit will act as a reducing unit. So overall, maltose turns out to be a reducing sugar. So the points of highlight that we saw in lactose were, so lactose, now in lactose, the first part that we saw was that they both are the monomeric units. Here are, now first one is beta D galactose, and the second one is beta D glucose. So these are the monomeric units. The second thing that is to be seen over here is the glycosidic linkage. Now the glycosidic linkage here is between the C1 and C4. Now I am assuming that you know that C1 is belonging to beta D galactose and C4 is belonging to beta D glucose. So this is the glycosidic linkage. And the third that we saw is that because of this anomeric carbon which remains intact in its place in lactose, so now we have got lactose as a reducing sugar, meaning that it is going to be showing both the Tollens reagent test as well as the Fehling solution test. So these are the points of highlight of lactose, which was a disaccharide made up of two monomeric units, that is beta D galactose and beta D glucose. Both of them are anomers of each other. Also, glycosidic linkage is between C1 and C4, and because of the presence of anomeric carbon, it will be a reducing sugar. So, these are the points of highlight in lactose, a disaccharide.